Hey guys, Beacon here. Today we'll be looking at a problem from today's Code Forces round, ones and twos. So in this problem, we're given an array that is filled with ones and twos, and we have to do a number of queries on this array. So the first type of query is we have to output whether there's a subarray with sum equal to the given number in the query. So a subarray is just a continuous section of an array. So in the first type of query, they give us a number and we have to output yes or no, depending on if there's a subarray with sum equal to that number. In the second type of query, we have to change an element in the array from a 1 to 2 or from a 2 to 1. So choose an element and we have to change that number to alternate it between a 1 and a 2. Now, first of all, let's take note of some things that should be fairly evident from the beginning. For example, if the required sum in the first query is bigger than the sum of all the numbers in the array we have, then obviously we can't find a subarray with that sum because a subarray is like equal to, smaller than the whole array, and if the required sum is bigger than the whole array, then it doesn't make sense. So we'll just output no in that case. Maybe another special case we might want to consider is when we have an array of just twos. In that case, it's quite obvious that we can create every even number up to the maximum size, of course, and we can't create any odd numbers because adding even numbers together only creates even numbers. So this all twos, this might lead us to consider parities. Parities is just odd and even in this case. So after all, ones and twos are very small, and it pretty much creates a lot of the numbers. So the only thing that limits us really in some of the cases is the odd numbers or sometimes the even numbers that we can't create. And since all the all twos example let us make any even number we wanted, this is always true. For any array, can we make all even numbers or all odd numbers? That might be a question you might want to ask. So to try and prove this and to continue the solution, we have to do something different. Instead of considering the subarray as a continuous section of the array as before, we will now think of it as taking the array and removing some elements from the beginning and some elements from the end, and what's left is obviously a subarray. So considering parity, we might notice from doing small cases perhaps that when the starting sum is odd, we can make all odd numbers, and when the starting sum is even, we can make all even numbers. And how do we prove this? Well, consider some random array, and we start off with a chosen parity, so for example, even. And then that means that at each step, we just have to prove to get all the even numbers below the original sum. We have to try to get like the original even number, that minus 2, that number minus 2, and so on. So we have to remove 2 at each step. So what can we do? We can take the original array, and if one of the endpoints, so if the starting number or the ending number is a 2, then we're done. We can just take that number out, and that's a subarray that's 2 less. Otherwise, if there's no 2, so it's both the starting number and the ending number are both 1s, in that case, we just remove the 2 1s from the beginning and the end, and we essentially remove 2, so we go down to the next even number. So we can generate all even numbers. This proves that if the starting number is an odd, we can generate all odd numbers, and if the starting number is an even, then we can generate all even numbers. What about the others? So the numbers that have different parity to the original sum. Well, notice that once we make an alternate parity number, for example, if we can create all evens, but once we make some odd number perhaps by removing some from the beginning and the end, we can make all numbers below that by repeating this minus 2 trick. So once we have the number 9, we can just minus 2 to get 7, 5, 3, and so on. So essentially, now the question is, what is the biggest alternate parity number that we can create? Once we create this biggest number, we can create every alternate parity number below it. And doing this isn't that hard. What we can do is, in the array, we can store the positions of all the ones in the array, because the ones are the ones that are changing the parities. And consider the leftmost and rightmost one. And for example, choose which one is closest to the end and remove that one along with everything to the left or to the right of it. This would remove an odd number because 1 plus a bunch of 2's removes an odd number from the original sum, meaning the parity changes, and this is the biggest alternate parity number. And then of course, using the -2 trick we've proven earlier, we can create any other alternate parity number below this number. And now in the query, we just have to check whether, the given number is one of these numbers we can construct. If yes, then we print out yes, otherwise we print out no. And yeah, that's the solution for this question. Thank you guys for listening, and stay tuned for more interesting and cool problems. Thank you.